acts of terrorism against commercial aviation experienced an upsurge during the 1980s, culminating with the devastating explosion of Pan American Flight 103 over Lockerbie, Scotland in December 1988. In that case, an intensive investigation revealed that a bomb was concealed within a passenger suitcase and placed in an aircraft luggage container transported in the cargo bay. When the bomb exploded, it destroyed the container, ripped through the fuselage, and caused the breakup and downing of the Boeing 747. A total of 270 lives were lost. In an effort to curtail the destructive potential of small amounts of explosives placed by a terrorist in checked baggage, the Federal Aviation Administration began investigating several methods of increasing an aircraft's resistance to blast effects. One approach to increasing the resistance of today's wide-body aircraft is to strengthen the luggage containers within them. Responding to this research initiative, the engineering staff at Galaxy developed the Explosive Containment System, or ECOS-3, a blast-resistant luggage container that exceeds anticipated hardening requirements. It also complies with standards for an LD3 container established by the Aerospace Industries Association of America, the International Air Transport Association, and the International Standards Organization. ECOS-3 is composed of individual panels which are constructed of an advanced fiber metal laminate material. Joined to an aluminum frame, these panels exhibit high strength, high impact resistance, low weight, and fire-resistant properties. The joints provide stiffness to the container and are attached to the panels through a variety of fastening devices. Corners are structurally reinforced. The panels have sufficient strength to withstand the preliminary forces of an explosion and are allowed by the joints to expand in a spherical fashion. Issues of durability, reparability, and operability have been considered in the design. Its panels are easily removable for either repair or replacement of a damaged area, driving down traditional recurring maintenance costs. Additionally, since the exposed surfaces of the container materials are made of conventional metals, they necessitate no special environmental handling or storage facilities. Exposure to the range of weather and temperature conditions typical of airport operations have no significant impact on the strength of the container.
The FAA conducted a series of tests to determine the effects on aircraft structures of explosive events in standard LD3 containers and secure luggage containers. In the first test, which was a baseline test, an explosive charge was placed in the standard LD3 container and detonated. Even though the charge size was smaller than that used in the ECOS, the LD3 container was completely destroyed, as would have been the case with the aircraft structure. In the second test, an explosive charge of the same size was placed in the standard LD3 container, which was then placed in the forward cargo bay of a pressurized L-1011. As shown, once again, catastrophic failure occurred. The aircraft was not protected at all. In the third test in March 1998, a charge size larger than those used in the two previous tests was placed in the ECOS secure luggage container. The container was then put in a wide-body fuselage section and the charge was detonated. The results were extremely impressive. Not only did the ECOS contain all harmful effects of the blast and protect the surrounding aircraft structure from all but cosmetic damage, but the container itself suffered no significant damage.
The safety of the air passenger is a major focus of Galaxy's mission as we continue to support the FAA's aviation security and safety-related programs. Our design, development, and continued improvement of ECOS 3 is an added measure of assurance and security for both the traveling public and the world's aviation community.